So each command on this level must have unique syntax. But for example, if we have a command called here, let's say resize, it can still be a subcommand resize on level 2. On one level, you cannot have a duplicated command with duplicated syntax. And also another restriction is on one level, you can have either static or either dynamic commands. You cannot mix them on one level. And the shell, when you will type the command, for example, root level 1, level 2, level 3, and level 4, will analyze the whole tree, and it will execute the command deepest found in the command tree, which have a handler. So for assuming that the command on level 3 has a handler, this command will be executed, and this one will be passed as an argument. But still, when you are in this handler of this command, you can still have access to syntax of level 2, level 1, and root command. I can show it in next slides, how to achieve that. Okay, so this is some example of built-in command which is in the system. Its root command is called resize. It's static. All root commands are static. Static, it means they are known during the compile time. Their name and their syntax must be known during the compile time. Dynamic command, you don't need to know the number and syntax during compile time. Okay, so this is how we register root command in the system. They are placed in the section variable area. So it's pretty similar to what we have in the legacy shell. So you define the command syntax without any quotes. Next, pointer to subcommands tree, help string, and the handler. This is how subcommand tree is defined. So it's pretty easy and pretty straightforward. Okay, and this is how currently handler looks like. So it's a bit different comparing to existing shell. First of all, it's not returning any value, but we will update that because we see benefit of returning values of commands. And it has one more parameter which previous shell didn't have. So it's the shell, it's the backend basically. So each command which are defined are available on all backends, but execution is for particular backend. So here are some useful subcommands which you should put in each handler. This condition, shell command precheck, it's checking whether the arguments which are passed to the command are correct, and it's also printing help if this is expected. And also it's checking if there are any options. Options are a bit similar to subcommands, but we are not recommending to use them because they cannot be auto-completed with the tab key. The only benefit of using options is that you can add parameter which can start with the minus sign. So because subcommands cannot start with this sign. Apart from that, we recommend using subcommands. Okay, so this is handler for resize command. This is interesting. So if argc equals 2, we print that it is unknown parameter. If it will be known parameter, then another handler would be called. So it will be called. We will have a called handler for default command. So that's why you can distinguish it like that. Okay, and now some maybe not demo, but this is what we did in the past, demonstrating dynamic commands. So let's assume we have a Bluetooth device which can connect and bond with some other device. And we implemented two root commands: connect, which has subcommand right now not known, it's only null and it's dynamic, and scan, which have on and off subcommands. So this is print script from actually how it was executed. So we want to type command connect, but there are no known hosts we can connect to. So we simply are scanning for known hosts. Application when scanned, all recognized hosts are now stored as a dynamic subcommands. So when now I type connect tab, it prints all found devices on the network. And when I type 4 tab, then only it limits to those which start with 4. So this is, let's say, one of the scenario where dynamic commands can be used. They are also used in the logger, but this can be explained by Krzysztof later on. And some plans for the future, some short-term plans. First of all, we want to change shell Rx to be interrupt driven, because right now we are observing some problems when pulling, when a lot of signs are transferred. For example, when handling escape keys, then escape key is not correctly interpreted, and we can see some artifacts related with that. And we want to add also a buffer, ring buffer for Rx. Of course, we also are working right now on migrating examples to new shell, and some long-term plans. We should add some more backends to Zephyr. Right now, we have only UART backend. Okay.
One question before you
yes,
continue.
Yes.
So you're not using the console subsystem because the console subsystem already has like the basic functionality to get a character and to over multiple backends. So is there, because we had this discussion on Tuesday about the console subsystem, and I was wondering whether the console subsystem should disappear entirely, be used by the logger and the shell, or be transformed into something else.
I'm not familiar with this, unfortunately. I didn't.
Carles, I think it's a topic to be discussed. Simply, if console stays, then we would need to have a console backend for shell, and that's of course not a problem. The problem that I see is that ideally we would like to have a console which multiplexes on line level, or how to say, the whole self-contained messages level, because now console has the byte access. So if multiple users of the console would access it, we could have bytes interrupted one message by another.
Okay, I see.
So I think the shell is there, the logger is there, and they have backends. And what go next is, I think, up to discussion in Zephyr.
Right, because right now it seems, or to me, it sounds like there's a certain level of duplication there. Obviously, also because the legacy logging and the legacy shell still exist. So that and those use the console, as far as I know. So. So we need, maybe this is a topic for the API next Tuesday, where if we can discuss that. We already signaled that we wanted to do that. So anyway,
yes.
outside of the scope of this meeting, but just to be considered.
Well, one thing why I let's say dislike console is this byte access API, and for the logger, when we want to output a lot of data and to not overload the system, we want to have something that can utilize like DMA transfers.
Right, understood. Okay.
So now it's demo time. I have connected my PCB with UART backend on, and I will use 1 second. I will use, for example, Picocom. Okay, so we are here. When I press Tab key, we can see all root commands registered by various of files.
Could you make the font a little bit bigger, if that's
yes,
possible?
Of course. It's. Please let me know where to change it. Oh, okay. Where is font size?
I think you had it in the view menu there. There was zoom in and zoom out. I think that will do it for you. You don't need this dialog.
Okay. Simply zoom in. Okay.
No, view in the menu on the top, the one you used, view. Yeah, and then
zoom in.
Okay. There we go. Yeah,
a bit
one
more.
maybe. Yeah, maybe one more would be good. At least in my screen, it looks small. Yeah, that's good. Thanks.
Okay. So let's start maybe with this resize command, which I explained. Let's check what it is doing. So this is built-in feature, help printer. So the function is responsible for printing and formatting the help text. So it gets a terminal size when someone changed the default width from, for example, from 80 signs characters. It ensures correct text print, because when you will see, for example, I will print some text, and new console is multi-line, so you can still, using arrows, go back and forward, and when once will change the width, this will go not correctly, as you see. So let's, it's not working. It simply assumes different size. So when I will call resize command, maybe you were able to see it was eye blink. Okay, now let's check how it's working. And now it's fine. It can be also see when I press the tab, you can see commands are in two lines, displayed in two lines. When I will make it wider, I will execute resize once more, they are only in one line. So right now, console is smart enough to format displayed text properly when we measure its width with this resize command. It's also resize default, but it is not working on this terminal. So when I checked it with PuTTY, it forces terminal to be 80 chars width, but it's not, unfortunately, it's not working on Linux terminal. I didn't figure it out yet why. Now let's still print a few commands, and there are also meta keys. So for example, right now I will press Ctrl+L. So this is the expected behavior. I can press Ctrl+W, so it deletes the previous string. Ctrl+E goes to the end. Ctrl+A goes to the beginning. What's Ctrl+C? It stays the old text and it does not execute it. Okay, so maybe now some dynamic commands. This is what I saw Nashif also tried on his movie. So execute, or maybe dynamic show. No dynamic command. So let's add few. Dynamic add, let's say ala Adam, commas, and now let's execute one. Dynamic execute, and when I press tab key, I see all these commands which were created, and I can execute them. So right now, to be honest, the handler is in execute parameter, and Adam was passed as an argument. And also let's test wild characters. So I can replace A with a question mark, enter, and you can see Adam has been executed, or with a star. Again, Adam has been executed. So this is how wildcard works. As I said, wildcards have some limitations. So limitations related with wildcards, it's that command which is expanded with the wildcard cannot have a handler. Also, subcommands below this command which is expanded cannot have a handler. It is because we would have multiple command execution, which we discussed internally some time ago, and to be honest, it might cause more problems than benefits. That's why we decided to keep it like that. Okay, is there Of course, there are some handy shell-related commands. So these built-in commands, for example, colors, I can off the command color. So this is default one. It is useful when one have a Bluetooth backend, because coloring font requires a lot of extra data which needs to be transferred through the backend. So again, shell colors on. It's also echo command. It can be used when one is using some kind of script to communicate with the shell. So right now I switched off the echo and I will execute test command. So it didn't print on the screen. So this is also to limit amount of data exchanged. Shell echo on. Okay, now the echo is again available. There is history command. So these are all recently executed commands. I can navigate using up and down arrows. So this also was not available somehow in the past. And Krzysztof, I will only maybe show a bit from the log. Start demo. So this is how logs are printed on the screen, and I can still type a new command. So as you see in parallel, you can do this. Later on, Krzysztof will maybe even show how you can filter these logs, because right now they are more or less flooding the screen. So you can in runtime filter them. Maybe this is all when we are speaking about the console. I want to only show how you can adapt shell to your needs. It's shell options. This is the new shell, and there are some parameters like what is really interesting. You can define what is the longest allowed command. So this also is because these data are these are buffers kept in RAM. So this parameter, using this parameter, you can limit resources usage. Shelled print buffer size, this is more or less like buffering before accessing UART directly to limit number of driver calls. And the maximum number of arguments, right now it's set to 12. If you enter a command which has more than 12 arguments, then all, of course, will be processed, but the 12th argument and following will be treated as a one argument. There will be passed as a one string. And this, you can also enable, disable most of the features which I show you also to adapt resources usage to your needs. Okay, so I believe this is all from my side. If you have any questions to this part, please let me know.
Jakub, could you please show the help? Because the console automatically builds and formats help on the screen.
Yeah, okay, let me do it again. So quite okay, I stop the log. So dynamic command, for example, has quite long help. So you can call it either like that or like that. So this is what console do automatically. When you register subcommand with its help, you only give the string, and what you see here is it's simply done by the shell engine. So dynamic command it explains what it does, and it explains all subcommands and what these subcommands are doing.
Yeah, I think it's also good to add that most of these user friendliness features can be compile time disabled to reduce the
exactly.
or RAM usage.
So it can be done by the kconfig, exactly.
So I think you can limit the size like even twice, I guess, by
or
removing.
even more. And according to Krzysztof's advice, we were using this is enabled macro, if I have it correct in my mind, to keep it compilable, but to not add it to the final hex.
So you can disable history, which takes quite a lot of RAM because you need to store the history commands. You can disable the help, default commands, and so on.
Mm-hmm.
So what's the approximate minimum size and maximum size with the config options?
That's a good question. I need to measure that. I remember some figure in my mind, approximately 10K, but I don't remember whether it was with the full or not.
I think that minimum, the shell subsystem at minimum is like 8-9 kilo. And then you can add more. Okay, if there is no further questions, then maybe I can share my screen and
Sorry,
present.
I'm not sure I understand that, Krish. 8 kilobytes of ROM.
ROM, yes, I'm talking about ROM, yes.
Okay, right.
RAM is mainly the stack of the thread, then the buffer for the command, and history, which, for example, if you want to store 8 commands, you get more or less multiple of 8 of command buffer. But of course, it can be optimized, but still that's the history. It's a biggest addition to RAM.
Okay, understood. Thanks.
I have this. Okay, stop share. So Krzysztof, you can take from here.
Okay. Okay. Let me know if you see the screen.
Yes, we can.
Okay, great. Okay, so the logger. It was actually introduced before the shell, as Anas mentioned. And here are the main features. So the biggest difference between the syslog and the logger is that it's deferred. It means that we try to optimize logging the log message to minimum, to take as few microseconds as possible, and defer all the time-consuming operations like string formatting or sending over UART. Those operations are deferred to the known context because normally logger is used everywhere, even in the highest priority interrupt. Once it's deferred, we reached something like 4 microseconds per log message at 64 megahertz on NRF52 board. So this is quite a change compared to the syslog. Then second thing is support for multiple backends. So you can have running at once altogether up to 9 backends. Currently in master we have UART backend, but there are 3 other in PRs, in pull requests already. So the number of backends will be growing. So you have very rich compile time filtering. So it's very easy to add a unique field severity level per module, and in kconfig enable and disable them as you want. This helps to reduce the flash footprint if you want, or basically to reduce number of logs you see on the on your backend. But apart from this, let's say, static filtering, we introduced runtime filtering. It means that you can, on runtime, enable and disable logs per module. And this is actually independent also per backend. That means that, for example, if we have 2 backends, one is UART and second one is, for example, flash log, and you want to log to flash only the errors, you can configure filtering for that backend to log only errors in the modules and have many more logs processed to UART at the same time. And we also have seen the need to have the filtering not only on module basis, but also on instance basis. For example, if you have a module which is very widely used, like for example, memory buffer, memory pool, and enabling logs in this module would be impossible because even Logger uses this module. But we provide something which is the instance level filtering, and then you can enable logging only on one instance, of course for your backend that you want. So this is quite handy because you have a lot of options to decide what you are seeing on the UART and what you are logging to Flash and so on. The Logger, because it's deferred, of course, it would not work nicely in case of hard fault or any other fault, because then you cannot use interrupts anymore and the thread. So the Logger has panic mode support. It means that once panic is communicated to the Logger, it can synchronously flush all the logs. It sends the signal to every backend which is attached, informing that we are in panic. And the backends which supports panic should reconfigure to blocking mode to not use interrupts anymore. And those backends which cannot handle that should shut down. Like if we would have logging over Bluetooth and over UART, then in UART you can send synchronous data, but on Bluetooth probably you need interrupts, so Bluetooth backend would stop working in panic, but you can still flush logs to UART or to Flash, for example.
So how does that work exactly, Krish? Yep.
Yes, so we actually today I created a pull request where I added this log panic call to all fault handlers, and on this call, Logger is sending panic or calls the panic function to all available backends, and backends react to that, shuts down on reconfigure and returns. And since that moment, any logs which are processed are, let's say, processed synchronously. So they are instead of putting messages to the buffer, we are directly calling the backends and getting backends engaged. And the backends which are still active are processing the string, sending it in blocking way over UART, and so on.
But that's not so that's not an immediate mode, right?
It is in the sense you mean this in place mode.
Well, yeah. So yes. Immediate as in the sense that synchronous, completely synchronous.
Yes,
so,
yes, it's completely synchronous, but it also adds the requirement to the backend that it cannot use any interrupts, because you can imagine that we are synchronously sending over UART, but this UART actually schedules DMA transfer, and but in this mode it's a requirement, the backend, that it cannot use interrupts anymore, because it's so it's not only that it's synchronous, but it's only in single context. It needs to stay in the context.
So outside of panic mode, is there immediate mode support?
Yes,
or plans?
Yes.
Yeah. Okay.
Yes, there is also it's called in place processing mode, where you can actually engage or call the backends and start the processing in the place where the log message is called. Okay. So it's of course maybe not that suitable for real life application, but might be useful in some simulator, for example. Yes, and we also, the design already has the multi-domain system in mind, so it means that it should be fairly easy to extend it to support multi-processors systems. As for the future, there probably will come much more new backends, like Shell is one of them. RTT, native POSIX. Those are all backends which are already in PR, or some of them are already in master. Probably somebody will add Flash or file system backend for logging to Flash, and other probably will appear. Like we can think about candidates like Bluetooth or network or Bluetooth mesh, whatever. And the multi-domain support, of course, will come if there will be a need. So okay, now I will show you a bit of first demo. This one is the example, the shell example. The shell complements very well Logger because it enables controlling of the Logger. As already Jakub shown, we have the simple demo where you can enable the logging, but also there are commands for the log itself. And you can do things like, first, maybe we can try to check the status. The status will print all available instances, independent instances of in the system, and will show us what's the log level, the current log level, and what is the compiled log level. This means that current log level we can change, but only up to the compiled log level, because everything above that we don't have basically compiled in, like debug messages here in that case. Now if I will start this demo, which just sends the log messages, we can see that we have logs from two modules. One is called app and second one is called app test. So they are basically one calls another. So we have the timestamp, which is also almost the same, of course. But now we can start to, for example, disable logs in this app test module, or reduce them to warnings only. Sorry, if I want to. Now I don't see any more info messages from that module because I disabled that on runtime. Oops, sorry. Sometimes I forget that this is a console on the device, not on the host. Now we can, for example, disable all those logs and all those messages.
You don't have built-in wildcards, Krzysztof.
Ah, yes, probably that's true. Okay, so now I will do that manually without the wildcard. Here you can already see the benefit of the wildcards is that you can disable or enable multiple modules at once. For example, if we have the instance level logging and we have many instances of the same module in the system, and we, for example, want to enable all of them, we can just use the name of the module and the star, and all will get enabled. So that's the one of the drivers of adding the wildcard to the system. So we can, as you can see, we can easily manipulate what we see on the system. Now, if we see that we have disabled all the logs in the app and app test, and because we have only one backend for now in the Zephyr master, we cannot show other features. But since the shell and logger is inspired or highly based on the NRF5 SDK shell and logger, I can present the demo coming from the example from Nordic SDK, where we have multiple shell backends. So as you can see now, I will just show you that now we have this demo we have one board, and we are using two transports, UART and Seger RTT, to the PC. So now we are actually have, in this system, we have 4 log backends: UART shell, RTT shell, flash log, and crash log. There is a distinction between flash log and crash log, because a flash log is a backend which continuously stores to flash messages which basically cross the filtering of this backend. For example, we can imagine that we want to continuously log errors to flash log, to flash. And we also have the second backend, which we called crash log. In crash log case, we actually want to store the tail, what happens just before the crash. And then maybe errors will not give us enough information. So in that case, we want to store also info and warning levels. So crash log will, in the standard application lifetime, will just keep the FIFO of let's say last 8 log entries. And when crash happens, it dumps all of those to flash, while flash log stores errors or given level continuously. So now if I, now what we might want to also have, maybe first I will show you, in this example, we have many more modules that can be controlled. For example, we have in our SDK, we have uptimer, which is kind of like a system timer. And we have multiple instances running in the system. We compiled in the debug level of logs, but only info is enabled on all of them, but and only the M timer 0 has logs disabled. So now, as you can see, if we would like to, for example, enable debug messages on all timers, we can do that with the wildcard. Now we will disable them because that was too much for us. Maybe we only wanted to see the logs from one instance. And as you can see now, I can, for example, enable the logs on one instance of this module. So this is quite handy. What else I can do is, because if we have the backends, for example, like flash log, it doesn't have normally it doesn't have medium to control it. For example, if you would like to store some statistics from one module into the flash, we then might want to enable or control the filtering of that module. And for that, we can also use shell, because in the log that we have the command which enables us to control another backend configuration. So here, if I want to enable messages on the console that I have above, so on the UART, I can actually control that using this second console. So of course, this maybe doesn't make much sense, but if we can also use this command to control backends like flash log or crash log and configure whatever we want. And actually, in what we have in SDK, and I guess it will appear here also, is that we can store this configuration to flash, and then on the reboot, this configuration will be applied to the logger. So I think this is all what I wanted to show you.
So some of this stuff, the log command is it currently part of the shell? Remind me.
Yes. So if we go back to the Zephyr, we have actually all those commands available.
Right.
But if we, for example, list backends present in the system, we only have one backend. So,
right.
And we can actually use this. So this is in place. So we can do like that.
Yeah. So obviously for things like storing the config, the last thing you showed, we would require then one non-volatile storage system to be present, but that should be fairly simple to do with config.
Yes.
And then adding backends for Flash. I think that's something. In fact, we could even consider the settings, using the settings system for the backend. So instead of relying on one particular file system, using this abstraction we have on top. To store the logs, and that would be actually, that might work well, but we probably need to think a bit more about this, but that's something we can think about for the future.
Yes.
I just want add one more thing. As you see, the design is quite flexible, and for example, you can have multiple of instances of Flash logger and basically direct different logs to different instances. The same applies to any basically backend. If you just store the default configuration in Flash, you are configuring that over the console, typing save, and this is done. It's also help in the debugging, that you have some debugging infrastructure that you are observing given parts of the system. You can configure the system that is ready for your debugging, then even if it crashes, your configuration remains. And with multiple backends, you can basically debug one backend using another. So when you are writing new backend for the shell, you can use existing backend to enable logs on that and check what is happening there.
Right. Yeah, that's really useful. And I'm also particularly interested in the crash lock on non-volatile memory. That I think will, even plugging it to some ideas that we've taken from other places, for example, using additional space in Flash that's not used, like for example the slot one if you have an MCU boot partition scheme. To store as much as possible there, to get as much information as possible. So that's things that we can think about adding in the near future.
So I have a question here. As most of you know, I mean, there's a lot of pull requests right now in the queue. They are changing or moving from the old syslogger to the new logger. And we have, I mean, since the logger has been merged, I think in August or in July, we have been like meeting all kinds of issues there, filing bugs, fixing them, and also based on latest pull requests, we still see some missing functionality or things that are not supported. So what remains to be done for us actually to move completely to the new logger from the syslog, and what are the major issues that we need to anticipate or need to be aware of when moving to the new logger?
I think the one thing that I have seen is some people complaining about the backends being not supported other than UART. So like the POSIX native, which is now in the pull request or even went in, I'm not sure. That I noticed could be one the blockers.
RTT, is that on a PR already or not? RTT.
There is a PR about RTT for a long time now. I think they need to adapt it to the recent changes.
Okay.
I think that transition strings might be the problem because the new logger in default configurations differs processing of the log. So you basically cannot use %s if the string you are putting in the logger is not available at the processing time, not at the logging time. And in some subsystems, this is problem as in multiple places you are relying on the fact that old logger was fully synchronous. And this is one very important note. We sacrificed the ability to log transient strings just to make it fast. There is a method to log things like binary blobs of data, which are presented as hex dump on the console, in which the data is actually copied in the logger. It is slower than the normal logging, but allows you to dump the data, which will disappear after exiting from the log macro.
It's like the problem is not the string being transient. The problem is the variable referenced by the string, right? If it's a local variable or something. Okay.
Yes, you can have it allocated
just to be clear.
on the stack. Yes.
Yeah. Okay.
Yes, that's we have pull request which handles that, but we apparently are not yet satisfied with that because that implies some awareness of the logger features to the user, and we are looking for a better solution than that.
So that's the main that's because that would prevent transitioning to the new logger by anybody who's basically logging a local variable, right?
Yes. Well, a local string, to be precise.
Yeah. Sorry, yes, local string. Yeah.
Basically, if you are passing a pointer and you want to have it dereferenced by the logger, which means that you want to print the string, basically it has to have valid dereference at the time of the log is processed, which means, for example, it has to be in flash. And if it's in static RAM, you have to be sure that it will be not modified until the logger process it, basically.
Right. Understood. But that's not that common, I guess, in general. Unless you're printing stuff that's in a buffer as a string that comes straight from, say, from a protocol or HTTP, for example. That would be a good example, right?
What the first one who requested that was Johan in Bluetooth, where they are logging addresses. So they build a string to build the Bluetooth address, and they pass that string to the log. So that is transient string then.
Right. Yeah, and I've seen the PR for that. Yeah.
Yeah. So I mean, that code has a circular buffer, so it doesn't immediately reuse those, but eventually it will. So you might not get the right address in the end.
Yes.
Yep. With the address, the situation is pretty simple because you basically might log each octet separately and use the format string, which formats that's out. But there are some situations that is not so easy.
Yeah, another example is the settings subsystem, because that one uses strings inherently. It has strings for both values. I think it's in base 64, and then also for the keys. So if you want to do any kind of logging of what you're doing with the settings subsystem, then you would need to find a way to duplicate the strings or somehow make sure that it stays persistent until it gets processed.